Hi guys. I miss being at school with you guys and I hope you're all doing well. Um, I just wanted to take you through some of the notes of things that we would have done if we were together, and hopefully this is stuff that's familiar, and so that's my goal, is to provide you with some things that you can do with the hopes that hopefully we won't have to make up this time if we're showing that we're getting some work done, and so that's my hope, just my hope. I don't know anything about that yet, but yeah, we're going to start with the Pythagorean theorem. We're going to go through this note sheet. I'm going to also post some extra notes as well. I'm going to post some Khan Academy videos. I'm also going to post some Delta Math optional practice. So if you feel like this isn't really helping you, give you feedback fast enough if you're on the right track, because that's going to be hard for me to do digitally, but you can still email me. I'm also going to post, like I said, the Delta Math assignments, and you don't have to feel like you need to do those. It's just if you want to try a couple problems and make sure you're on the right track first. It's just for your own personal use. So we'll get through this together. If you have questions, please feel free to email me. I'll be checking my email throughout the day. Yeah, so we'll get through this. But first thing is Pythagorean theorem. We all know this, so we've got a leg, and then hypotenuse, and we know C is the hypotenuse because it's the one that is opposite from the right angle. So the formula is a squared plus b squared equals c squared, leg squared plus leg squared equals hypotenuse squared. And then make sure when you are finding the missing side length, like for number 1, it's the hypotenuse, make sure you're taking the square root at the end, and it says give your answer in simplest radical form. So I don't want decimals, I want radicals. I will also try to find you a nice calculator online where you can calculate sine, cosine, and tangent if you don't have that available on phones, but I think they usually do, but sometimes we want those as well. Okay, special right triangles. Now this is the part that's a little bit tricky, so it might be helpful to look back at some resources of where special right triangles came, so you might want to look at the additional Khan Academy videos there. There's ones that are in-depth about 45, 45, 90, and 30, 60, 90. But this is the idea that 45, 45, 90, we're working with an isosceles triangle. So each of these legs I'm just going to call x, and I know I don't have those labeled right now, but each side length is x, which means that if I were to use the Pythagorean theorem, my hypotenuse would end up being x root 2. The reason why is because if I add x squared plus x squared, I would have 2x squared. If I take the square root of that, I can simplify the x squared to get the x, and then I still have the square root of 2 left. Conversely then, if you wanted the hypotenuse to be x, that means the relationship for the legs would be x root 2 all over 2. That's a little trickier, but that's in green right here. Okay, 30, 60, 90, we're going to call the shorter leg x. Okay, so I'm looking at the stuff that's in blue right here. The shorter leg would be x. And then I'm going to say that your hypotenuse is 2x. That's the relationship between the two. So if we solve for this side, our side here would be x root 3. Again, x squared plus, or 2x squared. Sorry, take that back. If I square the hypotenuse, 2x times 2x is 4x squared, minus x squared would get me to 3x squared for this side length. If I take the square root of that, that gives me the shorter leg of x root 3, because we can simplify the square root of x. Okay, another alternative is, again, what's here in green. If your hypotenuse is x, your shorter leg would be 1/2 x, or x over 2, and then the longer leg would be 1/2 x root 3, or x over 2 root 3. Okay, so again, simplest radical form, you're given some information, you're given what type of special right triangle you're working with. I'm going to talk you through one of those examples really quickly. So let's look at number 8. Okay, this is the one that's on your page here. So I'm given that the short side is 5 root 6. The reason I know it's the short side is because this angle right here is 60 degrees. So this angle has to be 30 degrees, which means this is my shortest side. Okay, so if I know that, I know that my longer leg is going to be S root 3. I called it S because for short side, and these sides are already labeled X and Y. So if we plug in S right here for X and S right up here, we'll have S root 3. So if I plug in S root 3, that's 5 root 6 times root 3. So I get to multiply 5 times root 6 times root 3, multiply those roots together, I should get square root of 18. Okay. Then I want to separate that out into perfect squares and leftovers. So my greatest perfect square factor of 18 is 9. And then times 2 gives me 18. Square root of 9 is 3. So I take 5 times 3 times root 2 to get 15 root 2. That's what the long side y is equal to. Okay, and then we know that the hypotenuse is 2 times the smallest side, so we're going to take 2 times 5 root 6. This one's a little bit easier, so we just end up with 10 root 6. Okay, so hopefully that helps a little bit there. Going back up to trig functions, this little symbol in the corner is called theta. It's a Greek symbol representing an unknown angle. Okay, so if you see sine theta, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOH-CAH-TOA. Okay. Reciprocal functions, remember reciprocal, that word means flip-flop. So for example, 2/3 becomes 3/2. So cosecant is the reciprocal of sine. We see that as 1 over sine. What I want you to think about then is cosecant, which is CSC of theta, is the reciprocal. So instead of opposite over hypotenuse for sine, we're going to do hypotenuse over opposite. Okay. Secant is the reciprocal of cosine. So again, reciprocate. Cotangent is the reciprocal of tangent. Okay, so just like this is SOH-CAH-TOA, this might be easier to remember if you keep it in that same orders. Cosecant, secant, cotangent are the reciprocals of sine, cosine, and tangent, and it's ho, ha, ayo. Some of you all appreciate that, I'm sure, but just trying to help you remember. Okay, so some examples to fill in the trig ratios. Let's take a look. So number 10, it says, given the ratio for cosine theta, find the remaining angles. Okay, so let me see here. What are we given? Because I have my stuff written over the top. Okay, so we were given cosine is 2/3. Okay, yeah. So that means if theta, I need to draw a triangle. I like to see the visual. You don't have to, but sometimes they don't give you the triangle. It might be helpful to draw it. Okay, so here's the deal. Excuse me. Theta is our unknown angle measure, so I'm going to place that in one of the angles that's not a right triangle. Or sorry, the right angle. So cosine, remember, is adjacent over hypotenuse. So I know that this side length has to be 2 because that's the side adjacent. And then this is the side that's the hypotenuse because it is the side opposite of the 90-degree angle. Then the side that's unknown right here is our side opposite. Okay, so if you can draw an arrow to the other side, or you can think of this angle encapsulates this side, so that means that this side is opposite our angle. Okay, so we first have to find that side opposite first, and then we can go through and figure out the trig ratios. Okay, so if I square 2, I get 4. If I square 3, I get 9. 4 plus, oh, excuse me. Oh, we're not adding. We have to take 9 minus 4, which is 5. So square root of 5 will be this side length. Okay, so to find the sine of theta, I'm going to take opposite over hypotenuse. That's square root of 5 over 3. We already have cosine. And then tangent is going to be side opposite over adjacent. So I'm going to have root 5 over 2. Okay, then I like to leave the reciprocal functions till the end. Then we just reciprocate. So you could, for the time being, just write that as 3 over root 5. Okay, that is the reciprocal. Technically, that's not fully simplified because we've got a square root in the denominator. So remember to rationalize. We take top and bottom by the times by the square root of 5. So our finished answer, which doesn't look more simplified but is because it doesn't have a radical in the denominator, is 3 root 5 all over 5. Okay, secant is the reciprocal of cosine, so that's going to be 3 over 2. Just reciprocate, flip it. Okay, tangent and cotangent are reciprocals. So first thing I would do is take 2 over root 5. Then we can recognize that it's not simplest radical form. So we're going to multiply top and bottom by square root of 5 again. And this says 2 root 5 over 5, but it's kind of fallen off the page. Okay, so I helped you remind you of the special right triangles here on this bottom part. And then it says find the sine, cosine, and tangent of all those special angles. In the future, hopefully when we're all back together again, we will go over this in more depth with the special right triangles and why these are so important. But it's going to lead us into some pretty cool things with the unit circle and trigonometry. I know you guys are pumped about that, right? Okay. I'm sure you guys like this part of geometry because a lot of this is geometry review with a couple new little things thrown in. Finding side lengths. Okay, again, using Pythagorean theorem, using sine, cosine, and tangent. SOH-CAH-TOA. So for example, number 5, I have this angle, I have the side opposite, and then I don't know the hypotenuse. So I would be using a ratio where I can use opposite and hypotenuse. That would be sine. So I'm going to say sine of 63 would equal 27 over x. Okay, so then what I would want to do is solve for x. First thing, multiply both sides by x. That gets x out of the denominator. Then I'm going to divide both sides by sine of 63. So it's kind of hard to see, but it says x equals 27 over sine of 63. Okay, for this it does say round to the nearest tenth. Okay, and then if you're trying to find an angle measure, this is where we do the inverse trig function. So sine, it looks like sine to the -1. We call that sine inverse of a ratio of opposite over hypotenuse. So if you plug that into your calculator on your phone, it should work. But we take sine inverse of opposite over hypotenuse and it will spit out an angle measure. Same thing for cosine. If I have the side length of adjacent over hypotenuse and I do cosine inverse, I'll get the angle measure. Okay. Tangent, if I'm given the two side lengths that are opposite and adjacent around the angle, then I do tangent inverse of that side length. So let's just go through 7 and 8. 7, this is the unknown angle measure. Okay. It looks like I have side opposite and then I have side adjacent. So what I would do for number 7 is I would use what ratio? I'd use tangent. Opposite and adjacent are my two side lengths. So I would set that up and I would say theta equals, like this one, theta equals tangent inverse of opposite over adjacent. So in this case it would be 8 over 14. Okay. Some cool applications of this are angle of elevation and angle of depression. Okay, so you got those to try to set up. My key points here would be, man, use a visual aid. So draw yourself a triangle, fill in the information that you know, and then try to figure out what it is that you're trying to find and decide if you're going to use an inverse trig function like what we just talked about, Pythagorean theorem, or using things like in 1 through 6 here. Okay, I'll post another video for law of sines and cosines. You guys got this? Let me know your questions.